Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and as part of our discussion on the different types of system strat that we are continuing for last few lectures, today also we will continue our discussion on falling stage system strat. So far we have discussed about the falling stage system strats in our last two lectures, where we have tried to understand what are the major processes that goes on during falling stage during the force regression, and as part of the force regression what are the different manifestations in terms of erosions, bypass or sedimentation, and what are the domains, what are the areas where sedimentation takes place, producing a typical falling stage system strat that we have seen starting from the fluvial system to the marginal marine to shallow marine to deep marine part. So, the type of these falling stage deposits that we have discussed so far in our previous lectures, and we have gone through several diagrams also to understand what are these processes and what are the resultant products. So, these falling stage deposits, they get preserved in the rock record depending on what is the overall magnitude of the base level fall and what is the location where that deposition is going on, where that effect of base level fall is going on, and with respect to this magnitude of the base level fall, how the shoreline is moving relative to the self edge, what is the position of the shoreline with respect to the self edge at the end of the fall. Because all these factors, as we have discussed in our previous lectures, that all these factors will finally control that what will be the exact nature of the falling stage deposits, what will be the character of the falling stage deposits at different parts of the basin, different areas of the basin. So, if I look at all the portions where FSST can form within a basin, so we can see that the shallow marine facies which accumulate on the continental shelf wall area during this force regression, as the shallow marine facies, particularly the coastal facies, the shore facies, they will prograde forward onto the shelf. They are most susceptible to subsequent subaerial erosion, because as the base level is gradually falling, so upslope part, the area which is lying upslope of the present shoreline is susceptible to subaerial erosion, and in such situations, particularly where this kind of gradual subsequent subaerial erosion is going on in response to the base level fall, there we can expect significant amount of erosion. This subaerial erosion, its extent will be higher if the base level falls below the elevation of the self edge, because in such cases the entire self area is exposed and is prone to subaerial erosion. So, depending on how much is the magnitude, how much is the amount of base level fall going on during the force regression, and how far of the basin is affected by this base level fall during the force regression, that will control what will be the extent of preservation of the falling stage system strat in that particular basin. The force regressive delta, which commonly forms successively starting from as soon as the shoreline starts moving and the river sediment starts getting dumped, we get the formation of force regressive deltas, and which get subsequently reworked, subsequently eroded, incised by the river systems, and gradually that prograding delta covers the entire continental shelf depending on how much the base level fall is going on. So, during this falling stage, these prograding delta tend to gradually thin out in the basinward direction, and assuming that at each and every phase equal volume of sediments are supplied by the river system, as it is gradually incising down, it is supplying same amount of sediments into the delta. Then gradually the accommodation available for that delta is decreasing, which will result in that the successive deltaic lobe, they will gradually thin out. But as they will be thinning out, they will try to laterally spread out. So, we can get wider delta lobes along the strike, but they will thin out towards the basinward direction. So, we can try to understand this with a simple diagram. Say for example, if this is the self area, and in that self area gradually the base level is falling down like this from here to here during the force regression. So, for the first stage, the amount of accommodation available for the delta to form is up to this much of accommodation is available. So, in such case, if I think of the delta lobe, it will be forming like this. So, we can have successive clinoforms producing the delta lobe over there. Now, for the next phase of fall, when the base level has reached over here at this point, now the amount of accommodation is less. So, the next delta lobe that will form towards the basinward direction will be something like this. So, it will be thinning out. The next one, when the base level is reaching over here, we can find out the next delta lobe is forming like this. Again, it is prograding delta lobes, but it is thinning out. So, successive delta lobes that will be prograding forward under this phase of base level fall in subsequent phases during force regression, we expect this kind of subsequent thinning of the delta lobe towards the basinward direction, which will be characteristic. So, in such cases, as I told you that if I assume that at each phase same amount of sediment is supplied, if I consider for this part the same amount of sediment, for this part same amount of sediment, and for this part again the same amount of sediments are coming in. So, what will happen now? Definitely, to accommodate that same amount of sediment over here within a smaller height, this delta has to spread along the strike of the basin. So, if I draw this section, so if this is the shoreline at that particular position, particular phase of base level fall, if the earlier delta was somewhere here, which maybe we are talking about this one. So, the delta which is forming here was something like this, the delta lobe was something like this. But the next delta, when it is reaching over here, the river will be incising down up to this, and over here will have much wider delta like this. So, this will be the consequence as subsequent phases of fall will continue during the force regression. We can get a changeover in the delta system, in the delta lobes in basinward direction as well as along the strike. So, definitely when we are getting much spreaded delta lobes which are laterally strike wise much wider, definitely there we can get much better reservoir connectivity. So, for the self delta sands, when we expect that should be a good reservoir, we should look for towards the late phase of the FSST, late phase of the force regression, where these delta lobes will be thinning, but they will be spreading laterally, which can result in formation of a better reservoir connectivity of the self delta sands. At the same time, the gradual steepening of the fluvial slope, it is taking place as gradually the base level is falling, it is covering up the self area. So, the overall gradient of the fluvial slope is increasing, that means the fluvial slope is getting steepened. So, during this force regression, such steepening of the fluvial slope gradually results in supply of more sediments from the source area towards the down dip direction, towards the basinward direction, and that results in coarsening down dip of the sediment, which is present in the offlapping delta lobes. So, in subsequent phases, when subsequent delta lobes are forming, the first one will have the kind of sediment or the grain size that will be relatively finer with respect to the next delta lobe. So, when we get more coarser sediments available towards the later phase of the delta lobes, which are formed during the late phase of the falling stage delta sands, falling stage delta formation, that will further enhance the reservoir quality when we look into these late falling stage deltaic sands. So, if I think of again at the initial part, the river slope was like this. So, for this river slope, maybe we can consider that the delta lobe was forming like this, where offlapping lobes are forming. So, this is the first phase, phase 1. So, for this particular slope, the river will have a particular energy condition, and in that energy condition it will create some erosion, and those erosions will supply sediments within this delta lobe. Now, the base level is falling down over here, and due to that now the river profile is taking a path like this. This is the new path. So, this is phase 2. For this phase 2, what we are getting over here is the new delta lobe forming over here. So, this is now the offlapping part, and these are the new delta lobes which are forming over here. So, these delta lobes, as it is formed by the sediments which are supplied by relatively steeper gradient of the river system, so the river will now erode more and supply more coarser sediments over here. If it goes down further, say for example, if it goes down to this level, the base level, the next delta lobe will be forming somewhere here, and in this delta lobe the base level will be coming down, the river profile will coming down to this level. So, again further erosions and supply of further coarser sands over here. So, in that way gradually as we move in offlapping delta lobes along the shelf, more coarser sediments will be available towards the late phase of the falling stage. And when these are more coarser sand, the reservoir quality is expected to be better. At the same time, these delta lobes towards the later phase are having more lateral continuity, more strike-wise continuity. So, that will result in a better reservoir condition, better reservoir sand deposit within this kind of delta formation. So, that is characteristic of falling stage systems tract. If I look into the short phase deposits, which are also simultaneously forming along with the delta lobes, because as the delta lobe is accumulating, it is getting reworked by the waves and the longshore currents, and those longshore currents and waves will try to distribute the sand, the delta lobe sands along the coastline, along the shoreline, producing the strand plain, producing the shore deposits. So, these shore deposits or the shore phase deposits, they will also prograde as the delta system is prograding during the falling stage. So, as the delta lobes are prograding along the shelf during successive phases of falling stage, along with that the shore phase deposits will also prograde along the shelf, and they will try to cover up the shelf area during the forced regression. So, definitely this kind of shore phase deposits, they are commonly sharp based because they are commonly associated with some initial erosional phases or maybe very drastic change in the facies type, as the earlier shelf deposits are commonly mud depositing condition, and over that suddenly this sand is coming, shore phase sand is coming. So, commonly they are very sharp based. Except for the earliest falling stage shore phase strata, when this forced regression is starting, the onset of the falling stage, at that time the shore phase strata which are gradationally based, because there the underlying sediments formed during the last HST are also shore phase sand. So, there the contact is more gradational, not very much sharp, but as the shore phase sand will prograde forward over the shelf, there will be a very distinct change in the facies, and that will result in a very sharp based progradation of the shore phase deposits over the shelf deposits. So, as we can trace the progradation of the delta lobe, we can also trace the progradation of the shore phase deposits which occur simultaneously. So, the preservation potential of this kind of shallow marine falling stage strata, the shore phase strata, the shore deposits, they are commonly inversely proportional to the magnitude of the base level fall. If there is high amount of fall, their preservation potentiality is low. If the level of fall is less, their preservation potentiality will be relatively higher. As the shoreline approaches to the shelf edge during the forced regression, will get a self edge delta that will form at the self edge, and the supply of the coarser sediment to the deep water environment that begins over there at that particular time. So, during this kind of condition, we get some other type of deposits in the deep water part, in the deep basinal part. So, when we look into the self area with respect to these shore sediments or with respect to these deltaic sediments, as the accommodation is drastically reducing as the base level is falling, so there will be a lack of accommodation, availability of accommodation, and that will result in overall lack of aggradation in the delta plain deposits. Or if I look in terms of the shore deposits, coastal plain deposits, they will also not show any aggradation during their stacking pattern. So, as the system is gradually prograding, so these regressive coastal deposits or the delta plain deposits, they will not show any aggradation, which will result in absence of the coastal topsets or delta topsets. Under such circumstances, the prograding shore face or the delta front deposits are truncated by the subaerial unconformity. So, this we can try to understand with a simple diagram. Say for example, if I am thinking of the river system is like this, and it is coming to the shore area, to the self area, and then we are going down to the slope and deep basinal part. Now, initially the base level was here at the start of the force regression, and now this base level is falling down, say for example at level 1 at time t1. So, when water level or base level is coming down over here, the accommodation available in this part is absent. So, this area will go through subaerial erosion and it will form unconformity surface, that we already know about that. Now, in successive phases, so for this particular erosion and river incision which is going on over here, we get a delta forming over here, the delta lobes are forming over here like this. Now, as the water level or base level will come down to this part, this area, the river will incise down to this point. So, we will get the offlapping remnants which will be available in the side by areas, in the interflow areas, and a new delta lobe will form over here like this. So, basically what is happening, if we think of a delta condition, normally we get a delta plain area which we commonly call as the delta top set, then we get a delta front, and then we get a bottom set. So, commonly this part is the pro-delta area, this is the delta front area, and this is the delta plain area, top set, delta front area and the bottom set area. So, this delta plain area, which is the delta top set, is not forming over here, it is not getting chances of getting aggradational pattern, getting aggrading over here just because of this lack of accommodation. So, what we are getting over here, straightway the delta front deposits, successive delta front deposits which are offlapping in nature, successive delta front deposits which are offlapping in nature, and that offlapping surface is nothing but the erosional surface. So, delta fronts, they are actually truncated at their top without any delta plane. So, we are getting delta, but the top part of that delta is truncated by subaerial erosion, by subaerial unconformity, and we are only getting the delta front, and this will continue up to the self edge when the river system will reach up to this, and we get the subaerial unconformity continuing up to this point. So, there we are again getting the delta forming over here, this is the self edge delta, there also we will get only the delta front accumulation, not the delta plane or delta top set accumulation. So, this is again another characteristic feature for falling stage system strike deposits. So, when we look into these shore face deposits, particularly if we look into the beach and upper shore face part, there definitely the sand bodies are accumulating along with the accumulation of the delta lobe deposits which are elongated and gradually downstepping. So, these sand bodies which are part of the upper shore face or beach, which are formed during the early phase of the force regression, early stage of the FSST, they will be abandoned on the subaerially exposed shelf as the base level continues its falling positions. So, as the base level is gradually going down, this already we have discussed in our previous lecture with the diagram. So, as the base level is falling down, the earlier portions they will gradually get abandoned because they remain within the interfluve areas and the fluvial channel that incises down, resulting in complete abandonment, complete bypass of these interfluve areas where these shore face deposits are preserved. So, these paleoshoreline sands are generally thin in the range of few meters, and they commonly occur as detached sand bodies because there, as we have discussed, the delta lobes which are forming over there, they are not that much laterally spreaded. So, their reworking process over there is little bit limited, and as a result of that, the shore face sand which is forming along with the delta lobe sand, their thicknesses are relatively thinner. So, when they are left behind as the remnant, they remain as detached sand bodies. Now, how much will be this detachment of these sand bodies? That will depend on the interplay of the sediment supply, how much sediment is supplied into the system, and what is the rate of the base level fall, because that will control that what will be the accumulation rate of the delta lobe, its reworking, and the accumulation of the shore face deposits or the shore deposits, and how much is the accommodation available. So, this will produce successive detached sand bodies in the upslope areas, in the upper part of the shelf or in the upper shore face area, where we get this kind of detached sand bodies. So, the reservoirs, if I think in terms of the hydrocarbon occurrences, the formation of reservoirs for hydrocarbons in this kind of early force regressive sand bodies at this early FSST stage are commonly represented by these offlapping and downstepping shoreline sands or shore face sands, which are abandoned on the shelf during the fall in the base level. If I look into the lower part of the lower portion of the deep water submarine fans, particularly if I talk in terms of the early stage of the falling of early stage of the force regression, we already know that at that particular phase we commonly get dominantly debris flow or mud flow, because the earlier sediments which are available over there, the high strand deposits, they are dominantly mud, and as the high energy conditions are prevailing during the falling stage, during the early falling stage, those mud will be eroded and they will be moving down the slope as sediment gravity flow, as debris flow or as mud flow, producing thick mud deposits. So, when you have dominantly mud deposit, it cannot be a good reservoir. So, at the early phase of the fall, we cannot expect good reservoirs to form in the deep water submarine fans, as there the sand is to mud ratio is significantly low. But when we look into the upper part of the FSST, that is the late phase of the FSST, there commonly we get significant amount of sand supply, as the nature of deposit during that phase changes, and there we can expect deposition of more sandy turbidites, as during the late phase the river incision reaches up to the shelf edge where the delta is forming and sand is supplied into the system now. So, that sand in the form of a sandy turbidite forming the part of the submarine fan now, that can act as a good reservoir. Similarly, if I look into the shore face area at the early phase of the falling stage systems tract, the shore face deposits are detached, they are relatively thinner. Whereas, if we look into the late phase of the force regressive stage, late phase of the falling stage, there the shore face deposits are relatively thicker, much wider, and they are relatively connected. We can trace them laterally along the strike for wider directions. So, as a result, in this kind of cases also the sand supply in terms of grain size, they are more coarser with respect to the earlier sediments, earlier delta lobes or the earlier shore phase deposits. So, all these factors control the reservoir potentiality. So, in terms of sediment budget, in terms of the reservoir quality, in terms of the availability of potential source rock and the sill rock, overall we can see that the conditions may vary from early stage of the falling stage, early phase of the falling stage to the late phase of the falling stage, which can again vary from fluvial to coastal to shallow water to the deep water condition. So, the reservoir condition, the petroleum play significance during FSST will vary significantly depending on in which area we are looking at, in which type of conditions are prevailing over there. In general, in the fluvial part, we do not expect much possibilities of reservoirs to form because there dominantly erosion is going on. But as we move into the coastal area or shallow water or the self-fall area, there several factors comes into consideration, and that controls the possibilities of formation of a good reservoir depending on what are the nature of sediment supply, what are the nature of distribution of those sediments during the falling phase, and more importantly, how much is the fall, how much is the amount of magnitude of fall going on in that particular basin. And also in the deep marine part, particularly during the late phase of the falling stage, we can expect good reservoir to form. So, we will continue this discussion in our next lecture also, where we will try to understand this aspect, that in terms of the economic aspect, in terms of the occurrences of natural resources, in terms of petroleum, coal or other resources, what is the significance of FSST. So, that we will discuss in our next class. So, we will continue this discussion. These are some of the references that you can follow for further reading on this particular topic. Thank you everyone.